Science on, come on, grab your friends, we'll learn about elements. Hey y'all, it's Lily Millie here, and welcome to our show, where we answer your questions about your concerns and curiosities about the wonders of science.
Recently, we have received videos questioning the topic of phase changes. Let's go check some out.
Hi Millie and Lily, I had some questions about water and what physical and chemical changes occur when it's changing, say, from solid to liquid, liquid to gas, and so on.
Great question, Blake. Evaporation, melting, condensation, vaporization, and freezing are all different processes of phases changing. Frozen water is called ice, and it freezes when it reaches 0 degrees Celsius. In order for ice to melt back into its liquid state, it has to be heated up. That's because when you heat it up, the ice steals the heat energy, causing the molecules in the matter to move more and more rapidly. When the molecules or particles move faster, they can no longer stay tightly packed due to rapid motion. This causes the molecules to break apart and loosen up into a liquid state. To turn this liquid into a gas, you have to vaporize it. To vaporize it, you have to apply even more heat by boiling it. When you boil it, the same process occurs within the molecules, except they move even faster, causing it to loosen up into its gas form, evaporation. Evaporation occurs at 100 degrees Celsius.
That's so cool, except what happens during the exothermic process when gases become liquids and liquids become solids?
Well, Lily, an exothermic process occurs when the heat energy is taken away and the endothermic process is reversed. The warm air, gas, hits a cold surface of a glass jar, window, cup, etc. It becomes a liquid again because the coolness is taking away the heat energy from the gas, causing the molecules and atoms to tighten up again and condense. When it is put in an even colder atmosphere, the same change occurs within the molecules, making them lose heat energy and tighten up. But this time, it changes into its solid state, ice. From there, the cycle continues, and the ice goes back to a liquid, then from there to a gas, then from there to a liquid again, and back to a solid. Come on, Lily, let's go see what that looks like. Here I will conduct an experiment showing the phase changes of water. First, you need a form of heat energy that'll speed up the process of the experiment. So I'll be using a pan on the experiment. You will be needing water in its solid form, ice. You'll be placing the ice on the pan and watching as it melts. As you can see here, the ice is stealing the heat energy from the pan, converting it to a water. As you can see here, the ice is melted completely into a liquid, and now the liquid is taking even more heat energy and creating gas bubbles. The gas bubbles are being released into the air as gas. In the next clip here, you can see that the gas bubbles are forming a lot faster because more heat energy is being used. To create condensation, I will have to hold this cold glass over the water. It will catch the air that is being released and condense. Now you can see that the glass is condensating and there's water forming inside of Inside the cup, you can see that there is water. Now, this is where the exothermic process begins. I'm going to put this glass in the freezer. The freezer is going to steal the heat energy away from the liquid that is formed inside and freeze up back to a solid. And the cycle continues. As you can see here, the water froze up inside and it's now a solid again. These are solid particles. These are liquid particles. And these are gas particles.
Let's take a look at another video from one of our viewers.
Hey Millie and Lily, I was wondering if you could tell me about the phase changes of dry ice. That would be great.
Good question. Dry ice is a pretty interesting substance. Unlike water, it goes from solid straight to gas. This process is called sublimation. Sublimation is a process where when it's conducted heat energy from another substance around it, it starts to move faster and faster, the particles I mean, creating a gas instead of a liquid. This gas is called CO2.
Wow, that's so cool. I didn't know that. Does it have a deposition process?
Of course it does. When it goes from gas to solid, it becomes a substance we call snow. but the scientific term would be disambiguation. The deposition process happens when the air gets so cold the CO2 particles freeze into small ice particles.
Wow, but what is the freezing point of dry ice?
The freezing point of dry ice is negative 109.3 Fahrenheit or negative 78.5 Celsius. This is what the temp has to be for it to be a total solid. Now let's talk about the endo and exothermic process. The endothermic process is when the dry ice takes in / absorbs the heat energy to become something else, in our case, CO2. The exothermic process is when energy is released from the substance. For dry ice, CO2 is what is released.
Whoa, I didn't know that. Nice.
Now I'm going to show you an experiment on the phase changes of dry ice. Let's go! Hey guys! Okay, so now I'm going to show you an experiment on dry ice. And you'll need parental vision. Don't try this at home. First you'll need a hot pan, gloves, and dry ice. As you see here, this is called the exothermic process, where the gas is releasing from the dry ice and it's sublimating. So this is going from a solid straight to a gas. This is it sublimating without any heat. As you see, this is sublimating so much more than it was just in my hand because it's being conducted more heat energy. So now the CO2 gas is being released faster. Add our dry ice to room temperature water. And this is the sublimation process when conducted heat energy from water. So now that we have added dry ice to lukewarm water, it is stealing all of the heat energy from it and creating huge CO2 bubbles. I don't know if you can see that, but right there. And when those bubbles reach the surface and pop, it just creates this really cool gas. Now we are going to add the ice to even warmer water. It is going to steal more heat energy, causing the ice to sublimate more rapidly. This one isn't moving as rapidly and as much as the other one because the other one has more heat energy. This is a great experiment. Now, please ask for parent permission before you do this because you could get seriously hurt. Thanks!
Now that that's over with.
This calls for a song.
Yeah.
And it's crazy right how cool the phase changes are. That's what I was gonna say. Never knew that sauce could go straight to gas. Jinx again. Who knew that vaporization could turn into condensation when a hot gas touches a cold glass? Say goodbye to the heat energy, 'cause this solid ain't a solid anymore. Energy is absorbed. Energy is released. Science so much more with endo exothermic. Science so much more.
Thanks for watching!
Not over just yet. Bloopers.
Okay, wait.
And it's crazy. Oh my god, bring it up! I
Get it? Pun intended. Uridocyclitis.
can't go that high!
Hey, Millie and Lily. I was wondering if you could tell. Wait, I forgot what I was.
Thanks for watching.